So essentially, there are two main ways that we describe sequences. We either talk about a position to term rule or a term to term rule. Okay? Now, in this video, I want to explain what we mean by the difference between those two things. So, a position to term rule is when you have an nth term. This is something you may have heard of previously, but we're going to be exploring all about that in the next 3 sections. Okay? So when you have an nth term, essentially it is a way of you being able to go, right, you tell me which number in the sequence you want. So if you want the 10th term or the 100th term or the 500th term, you tell me which one you want. I'll substitute n is 500 into my formula, and that will tell me the 500th term. So, for example, notationally, we quite often use un to mean the nth term is equal to, and it could be something like 2n plus 3. And if you tell me you want the 500th term, then u500 would be 2 times 500 plus 3, so that's 1003. So the 500th term in the sequence would be 1003, and I could work that out immediately. So you tell me the position, I'll tell you what the term is. Okay, so this is a position to term rule. This rule tells you how to get to any of the terms in the sequence. Alternatively, you can have a term to term rule. Now, what that means is that you have a rule that gets you from one term to the next. So it might be that there is a rule that says that we need to multiply by 2 and then add 1. And this is the rule that gets you from one term to the next. And you would have to have a starting term to get there. So let's say we also said that the first term, u1, was equal to 3. So to get to the second term in the sequence, I would need to multiply the previous one by 2 and add 1. So I do 3 times 2 plus 1. So that's 6 plus 1 is 7. And to get the third term, I need to multiply the previous term by 2 plus 1. So 7 times 2 plus 1 is 15. And so on and so forth. But if you asked me to work out the 500th term in this sequence, if this is all I've got to go by, then I need to first of all work out what the second term is, then I need to work out the third term, then the fourth term, then the fifth term, then the sixth term, then the seventh term, then the eighth term, and so on and so on and so on and so forth, until I arrive at the 500th term. So unfortunately, this one requires me to kind of keep cranking the handle until I arrive at the position I want. So in that way, it's not a particularly kind of useful thing for me to use. It's not going to get me to the answer quickly. It is generating term by term, as the name suggests. Now, notationally, you can see sequences written like that, or it could be in words. Algebraically, instead of writing this, the notation that you would move up to, particularly at A level, would be this notation where you would say that the next term in the sequence, so this represents the next term, is 2 lots of the previous term, so 2 lots of the previous term plus 1. So this is what we refer to as a recurrence relation. And it describes exactly what you have here. It's just algebraically, that's the notation that we use. So in a nutshell then, position to term, these are nth terms. Okay? You tell me which position you want, I'll find you the term. If it's a term to term rule, then you are cranking the handle, first term, then the second term, then the third term, then the fourth term, then the fifth term, etc., in order to get to whichever term you need.